Today we are going to see about attenuator. So I am Reggie, Associate Professor, Department of ECE. Once we know the attenuator, students will be able to define attenuator, classification of attenuators. Attenuators. An attenuator is an electronic device that reduces the power of the signal without appreciably distorting its waveform. An attenuator is effectively the opposite of an amplifier, though the two work by different method. While the amplifier provides a gain, an attenuator provides loss or gain less than 1. Attenuators are usually passive devices made from simple voltage divider network used to control the amount of microwave power transferred from one point to another. Reflect and absorb the energy in some of the dissipative element. Attenuation is the function of frequency. Two types of attenuators: fixed attenuator, variable attenuator. Fixed attenuator in circuit are used to lower voltage, dissipate power and to improve impedance matching. Fixed type of attenuators are commonly used where the fixed amount of power is to be provided. If such type of attenuator absorb all the energy entering it, so we call the waveguide terminator. This normally consists of short section of waveguide with the tapered plug of absorbing material at the end. The tapering is done for providing gradual transition from the waveguide medium to absorbing medium, thus reducing the reflection occurring in the medium interface. Dielectric used as glass. Attenuators also used to match impedance by lowering apparent SWR. Fixed attenuators, it is the having center, it is having shorting pole, microwave power is inserted, W be the width. So when this inserted here, a dielectric sab will be there. Using that one we can perform performance characteristics of fixed attenuator: input and output impedance, flatness with frequency, average and peak power handling capability, temperature dependence. Variable attenuator provide continuous or stepwise variable attenuation. For rectangular waveguide, these attenuator can be flap type or van type. For circular waveguide, rotatory type is used. Variable attenuator, flap attenuator, movable van attenuator, variable type waveguide attenuator, rotatory van attenuator. Flap attenuator. Flap attenuator consists of resistive element or disc inserted into the conditional longitudinal slot cut along the center of wider dimension of the gate, which is responsible for attenuation. Flap attenuator. Flap attenuator is mounted on the hinge dam, allowing it to descend into the center of waveguide. Degree of attenuation can be determined by depth if association. Movable van attenuator. The van positioned at center of guide can be moved laterally from center, where it provides maximum attenuation to the edges, where the attenuation is considerably reduced since E lines are always concentrated at the center of waveguide. Variable type attenuator. In a variable type attenuator, waveguide attenuator, resistive van attenuator is moved from one side of the wall to the center by using screw, where E field is considered to be maximum. This resistive film is shaped to give linear attenuation. Rotatory van attenuator. A resistive rotatory van attenuator provides precision attenuation with an energy plus or minus 2.1% of indicated attenuation over the operating frequency. It consists of three vans. The central van, rotating type, placed at the center section of cross-section waveguide, arranging tapered on both sides. Rotary van attenuator. The most satisfactory precision attenuator is rotary van attenuator. The structure of the attenuator is shown in figure. It consists of two rectangular to circular waveguide tapered transition along with the intermediate section of circular waveguide that is free to rotate. All the three sections contain thin resistive cord. The input signal passes from the first cord with negligible attenuation because the electric field of TE10 mode is perpendicular to the cord. Then the wave enters through the transition to circular waveguide. The attenuation is adjusted by rotating the circular waveguide and the resistive cord within it. The field of TE11 wave mode can be divided into two components, one perpendicular to the cord and other parallel to the cord. The latter component is absorbed by this cord. The former component enters the output of the gate, in which it again the component parallel to the resistive cord is absorbed. The plates are usually thin with epsilon r equal to 1 and the conductivity sigma of the finds 0 value. The plate attenuates the value that is traveling, and the amount of attenuation is dependent upon the property of the material from the plate is made. The dimension of the slab and the angle between the electric field of the input and plane of resistive cord circular section. The attenuation is mentioned in decibel. Attenuation dB equal to minus 40 log cos theta into dB. So here we are studied about what is a attenuation, what are the types of attenuation, what is a fixed attenuation, and what is a variable attenuation. Thank you.